Hi everyone, welcome back to Abrar channel. Today we are going to discuss a topic called process capability, right? Whether the process is capable or not capable, we conduct a study called process capability. And this is an important segment from the Six Sigma perspective or from the statistic perspective, right? And from the Six Sigma perspective, there is something called DMAC approach. In the measure phase, the process capability is being carried out to know whether the process is capable or not, right? And the same thing you can repeat again after the solution has been deployed. You can repeat again to know whether my process is healthy or not. You can do check also as well with the help of the other tools like control chart and so on. Let's get back to this topic. And as I was briefing in the previous video that the data is important. Depending upon the classification of data, your tool will vary. Exactly in the same thing, even in the process capability also no different. Meaning, if your data is variable data, you can use process capability like CP, CPK, PP, PPK you can do. What is CP? Process capability ratio. What is CPK? Process capability index. And PP, again performance, right? You can do a performance ratio or performance index. And then if your data is a discrete data, you will not be able to perform the CP, CPK and all that, right? You can do what you can do the max, you can do defect percentage, you can get to know the yield percentage, and you can further calculate like DPMO, you can further calculate PPM, you can further calculate sigma value, whatever the things you needed, you will be able to do, right? This is the two things are there, right? So let's get back to this variable and the entire thing. There is also a very important point is notably is you whatever the data you have, you need to test your data is normal or not normal. So to do that, very simple, in the menu tab you can go to stat and then all the way, if you just hop on to this, it will go normality test. In the normality test, you can have a click, put the value, and then if the p value, right, if the p value is greater than 5 percentage, that means the data is normal. If your p value is less than 5 percentage, meaning your data is not normal, you have to still you can carry out the process capability. Only thing is you cannot do it a normal way, but you need to pick up one of the thing like variable is one of the method is being used. Variable process capability, variable process capability, you have various things like log, exponential, lot many techniques are there, but variable is internationally acceptable model also as well, right? So this is the one. So far what we discussed that process capability, if you have a variable data, you can find out CP, CPK, PP and all that you can find it out. And there is something called, if you have discrete data, you can find out the yield, defect. Furthermore, you can find out the resultant value, for example DPMO, PPM, sigma value, all these you can easily find it out. And then the second portion which I talked about it, if your data is not normal data, non-normal data, meaning what is meant by not normal data? If you look at the trend like this is your data, this, and if your data is like this, that's called a normal data, right? That means data is online, right? That if you, this is a percentage, like coverage is on the line, so that means the data is good. So typically you will get more than 5 percentage, you will get it. That is called data is normal. If your data is not normal, what you will get it? Maybe I'll put it up here. Like this is your distribution of histogram. I mean this is your example like normality test you are doing it, and you will get it like this. That means almost like 2-3 histogram you can form further that. That means the value will be very less than 5 percentage of p value, right? And that means the data is not normal. If the data is not normal, you need to do variable method. If your data is normal, you can carry out process capability. Is only one process capability you can do, or 6-pack also you can do, right? I will talk about what is 6-pack and all that. Okay, let's get back to this first basic thing called CP, process capability ratio. You all know the formula, USL minus LSL by 6 sigma, right? So process width, so tolerance width divided by overall process width is USL minus LSL by 6 sigma. So this one actually, like if you can, for example, let's say whatever the target you have, let's say target is 100 and you have a tolerance of 10, right? That means 90 is your LSL, 110 is your USL, and the mean, the middle one is the target, that is 100, right? And then 6 into that, this sigma is nothing but standard deviation, how much standard deviations you have, and that is spread, right? So you will be able to get to have the CP. CP is actually, it takes the process specification and whatever the customer target has been given, it takes it. But CPK is widely used than CP. The reason is, it takes the process average into consideration. So the formula itself, you see that USL minus X double bar by 3 sigma, whatever the minimum value, or X double bar minus LSL by 3 sigma. For example, I get it like 1.2, here I get it 1, that means I have to consider it as 1. Minimum of, from these two I substitute whatever the minimum I need to substitute. So therefore, CPK value is, CPK is widely used because it's indexing. It takes about the process centeredness, how the process has been centered. This is actually overall. This is your overall process width, and this is your actually your tolerance width and process width, right? But actually, if you look at this CPK, indexing, the word indexing is how values are close to your target, close to your mean value, close to your the middle line. That is what the indexing, and CPK is very powerful than CP. What is the normal general rule is 1.33, and that means that is equal to 4 sigma, and automotive 1.67 is the rule. So let's talk about this one. Easily we can remember 0.33 is 1 sigma, and 0.66 if you are getting CP or CPK equal to 0.66, that is 2 sigma, and 1 is 3 sigma, and all the way goes like 1.33, that is a normal rule, that is 4 sigma, 1.66 or 1.67, that is 5 sigma, and the 2 is 6 sigma, and then further 2.33 is 7 sigma, 2.66 is 8 sigma, and the 3 is 9 sigma, and it goes further, right? This is the value, standard value. How it gets calculated, I have already dwelled in my past video. You can take a look on how to calculate these portion as such. Let's come back to this one. When you have a process capability, you can just check the process capability, right? When you go to many in the many tab, how to do it? Very simple. Go to stat and then go to quality tools, because this is one of the quality tools, and then process capability, right? And if your data is normal, you will declare normal. If your data is non-normal, you will declare as non-normal. Let's assume that your data is normal. Let's say it will give you like one histogram with all the, on the left side you will have a details like what is the N value, what is the LSL, USL targets, what is the standard deviation within overall, all this it gives. And the right side it also gives that this value like 0.33 or 1.33, whatever the value, right? If it is 1.33, it means that the 4 sigma process is capable. Anything less than 1, process is not capable. Above, if it is 1.33, is capable, and then more than that, it is a good to have, right? That's what it denotes all about. And then 6-pack actually gives you more complete holistic picture. For example, it gives that, for example, your data is only one variable data, then IMR chart, IMR chart it gives it, and then how the values have been spread it gives it, and then it gives it the histogram, and then in the LSL, USL, how the value has been there, whether it's been skewed or not skewed, all this it gives it. And then probability one, that's what I talked about, right? 5%, less than %, it also gives a probability chart. And then finally it also gives it overall summary also as well. Then in a simple line it also gives it. That's 6-pack. 6-pack that also I have done so many videos on 6-pack, you can take a look on that. And then further lastly we can have discrete data. If you have discrete data, it's quite straightforward. For example, let's say 2 out of 100 product is being failed. So 2 divided by 100 is 2%. Yield is 98%. And then when you substitute into that DPMO, you will get to have that DPMO value, and then you can in turn convert into sigma value and so on, or PPM value. All these you will be able to do with it. And more importantly, in all of these things, so data is important, and data type is important, and your normal, you need to always check that normality test in order to prove that whether your data is normal or not. One of the other thing is while taking it, you should take care, due care, because actually if the process is not capable, and you need to figure out the root cause, and we should not remove the value, but in turn you need to figure out the cause and fix the cause. And if you get that less than 1, That means according to the TQM book, it says that actually we need to immediately take the corrective action, figure out the cause. Either you tighten up, loosen up the tolerance, or you just work towards to reduce that standard deviation. When the standard deviation is being reduced, what will happen? CP or CPK value will go up. When the CPK value goes up, automatically your sigma value will go up. This is all about the process capability using that whiteboard, and I have done so much of videos on using the Six Sigma, using the Minitab, using the Excel. I have done it, so you can take a look on that. Please do like, share, subscribe my channel. You have a wonderful day ahead.